Good morning, guys. So I have already uploaded the assignment to Canvas, and some of you might have already done it. So I am doing this video just because some of the concepts can be a little bit hard to understand if it's your first time seeing them. So the unit is forces and motion, and we're gonna have three different chapters in this unit. But today we're gonna talk about the kinematics. So first thing you need to know is that most of the quantities used to describe motion can be categorized as either vectors or scalars. A vector is described by the magnitude, so that's the size, and the direction. For example, where is Big Spring? The answer would be 40 miles east. 40 miles is the magnitude, and east would be the direction. Scalar is described by magnitude only, so no direction. For example, how fast is the speed limit? 70 miles per hour. That's the magnitude. So a quantity that is ignorant of direction is referred to as A, scalar quantity, B, vector quantity. A quantity that is conscious of direction is referred to as A, scalar quantity, B, vector quantity. So we know that scalar quantity is the one that does not take direction into consideration, only the magnitude. Then for the second question, the answer would be vector quantity because the vectors are the ones that take into consideration both the magnitude and the direction. And you guys can click on this link and watch this video on your own time. It's about which movie have you heard the word vector. Okay, chapter 1, kinematics, which is the study of motion of an object without regard to the causes of the motion. So what that means is that it studies the motion, but it does not consider what caused that motion. Reference point and motion. So observing motion is more than just observing an object. You have to observe the object in relation to a stationary object. Stationary object will be something that's not in movement, something that will stay the same in the same location, does not move. The stationary object is called a reference point or a frame. When an object changes in position relative to a reference point, then it is in motion. So if you see these pictures, we have a mountain, which will be the stationary object because it does not move, and we have the hot air balloon, which is in motion. So how is it moving relative to the mountain? How is that hot air balloon moving? So in the left side, you have the hot air balloon lower, right? It looks like it's lower in altitude. And then in which direction would you say it's moving on the right side, on the picture on the right side? What would you say about the direction in relations to that mountain? Is it going northeast? Like, what do you guys think? Next, we have distance and displacement. So if you already did the PowerPoint, or you can access this video, it's a video in Khan Academy explaining what distance and displacement is. You can watch that. So pause this video, go watch that one, and then come back to this video. We're going to talk about first about distance. Distance is how far an object travels. The amount of ground an object has covered does not depend on direction. So imagine an ant crawling along a ruler. What distance did the ant travel? So it started at 0 centimeters and now it's at 4 centimeters. So what distance did the ant travel? We will say the ant traveled 4 centimeters. So like we said, distance does not depend on direction. So now the ant is starting at 4 centimeters and it's going all the way to 0 centimeters. What distance does the ant travel now? It went from 4 to 0. So the ant traveled 4 centimeters again. Did the change in direction change the answer? No. So now the ant started here and went all the way to 0. That is still 4 centimeters. So the direction does not change the distance. Now let's follow the ant again. Went to 7 and then it stopped at 4. So it went to 7. So we know it went 7 centimeters and then it went back this way. So that'll be 8, 9, 10. We're adding the centimeters. So this way it went 7 centimeters. And then when it went backwards, it went 3 more centimeters. And you're going to add those two to get a total of 10 centimeters of distance traveled by the ant. When we talk about displacement, we're talking about the change in that distance. So the starting point minus the final point. So displacement is where you are in relation to where you started. The overall change in position from start to finish. The equation's right here. That triangle means change. The x, remember from before, it's a distance. And it equals final minus initial. Okay, now let's see our friend. What is it going to do now? So now we're going to find the ant's displacement. So the starting point was 0 and the end point was 4. So if we do the equation, change will be 4 minus 0. That's going to give me 4 centimeters. So that ant was displaced 4 centimeters. Don't forget that we need to include the sign because it's going to tell us the direction. It was going to the right, and here we have that to the right would be positive. So it was going, that positive sign tells me that the ant went to the right side. So now you're going to find the ant's displacement again. Starting at 4, and it's moving to the left. So my starting point was 4. Starting point was 4, and my end point was 0. So 0 minus 4 is going to give me negative 4. And I can say that is true because the ant went to the left side, and the left side would be negative. Now find the distance and displacement of the ant. Again, the ant's going to 7, and then it went to 4. So for the distance, we first have 7 centimeters, right? And then we have, it went back 8, 9, 10. So 3 more centimeters. So again, we add these two, and we get 10 centimeters. Now to find the displacement, we need to find the starting point. It started here, start, and then it ended here at 4. So I need to do change in x. My end point is at 4 centimeters minus my starting point, 0 centimeters. So the displacement equals 4 centimeters. Now, what is the displacement covered by the car? So the car started in town A, and it went all the way here to town B. And we know that that distance was 25 kilometers. Now, my starting point was town A, my my final point is town B. And the problem is already telling me the distance between town A and B. So it's already telling you the displacement. But what we did not cover before was what? We said the distance was 25 kilometers. We knew the displacement was 10, but what is the direction? So here you have north, south, west, and east. So displacement is 10 kilometers east. Now our next example, we have Tim, it's going to school, right? Is walking 4 meters to southeast, right? And then 3 meters north. So for the distance, we're gonna have 4 meters plus 3 meters, and that's gonna be 7 meters. So Tim walked 7 meters to school. For the displacement, I need to say, Tim, this is your starting point, 1, and then this is the final point, 2. What's the distance between 1 and 2? The problem is already given to you, 5. So your displacement is 5 meters. And let's not forget the directions. 5 meters where? To the northeast. In our next example, we want to know the distance and the displacement. So for the distance, I'm going to add 2 plus 4 plus 2 plus 4, and that's going to give me 12 meters, right? Now, the displacement, let's say this is my starting point. I went 1, 2, 3, 4, and it takes me to the exact same place. So that means that my displacement is 0 meters because I started where I ended. So displacement equals 0. Now this one's a little bit tricky, but I'm gonna explain it to you. So the football coach paces back and forth along the sideline. The coach moves from position A to B, then from C to D. So here's position A, right? So he's gonna go from between these two, we know it's from here to here, we know it's 10 because it goes 50, 40. So he's going 10, 20, 30, 35. So from A to B, from A to B is 35 yards. Now you gotta go from B to C. So here we are, and we're gonna go to C. So this is from here to here is 5, 10, 15, 20. So the distance is 20 yards here. Now we gotta go from C to D. So C is here, and we gotta go all the way to D. So 5, 10, 15, 20, 25, 30, 35, 40. 40 yards. Now I need to add all those to get the distance. So 5 plus 0 plus 0 is 5. 3 plus 2, 5 plus 4, 9. So 95 yards is the distance that the coach pays. Now to find the displacement, I need to see how far is A from D. So for the displacement, I need to find the distance from A to D. So A is here, so 10, 20, 30, 40, 50 plus 5. 55 yards, it's the displacement. Now this is your practice problem. You're going to be using this top part to find the distance traveled and the displacement. For example, the first one says an object moves from point 1, right here, point 1 to point 4, then it reverses and ends in point 2. So it went from 1 to 4 and then it went back to 2. So the distance traveled will be, we know, 1, 2, 3, and then it reversed 4, 5. So distance traveled 5. The displacement from the start point to the end, from 2 to 1, is just 1. Okay, you guys can do the rest. Let me know if you have any other questions. I'm here to help you.